Science
Cloud.
Here I have a circuit with a battery, light bulb, and gap. If I fill this gap with a metal, the light comes on. If I fill this gap with glass, the light stays off. You probably already know this because metal is an electric conductor and glass is an insulator. But what happens when I fill this gap with a silicon wafer? The light stays off, so you might think the silicon's an insulator. But what if I heat it up? Thank you. It lights up. The silicon is insulating at room temperature but conducts electricity when it's very hot. It's a semiconductor whose conductivity changes based on the environment. This special ability makes semiconductors the perfect brains for electronic devices. Circuits of small semiconductor switches, called transistors, are at the heart of computer chips and enable them to do math and run programs. Semiconductors have enabled electronics to become smaller, faster, and more reliable. But what is it exactly about these semiconductors that allow them to either conduct or insulate? In a single atom, electrons can occupy specific energy levels. When multiple atoms bond, the electrons are shared between them. But because the atoms are now interacting, the energy levels shift around. In a solid, trillions and trillions of atoms interact with each other. Their individual energy levels smear into energy bands. For a material to conduct, the electrons must be able to jump from lower energy states to higher ones. The spacing of these energy levels and how they're filled with electrons determines if the material is a conductor, insulator, or semiconductor. If there's a huge gap between the lower energy levels and the higher ones, it's hard for electrons to jump to the higher ones, so current can't flow, and it's an insulator like this glass. Metals have no gap at all. Electrons can move to the higher energy levels with no problem. Current can flow. Semiconductors fall somewhere in the middle. They have a medium-sized band gap.